Hi everybody, today I'm going to show you how to render images of crystal packing diagrams in Blender. And the real advantage of getting this type of view is that you can not only see the molecule itself, but how it interacts with other molecules in the crystal structure. And so a couple of things that I'll be going over today are how to import extended crystal structures into Blender from CIF files, setting up the depth of field really to focus in on one molecule in the crystal packing diagram, and then adding textures to atoms to give a little bit of complexity to the scene. First, let's go into Mercury software. Next, let's open the CIF file that we'd like to get the crystal structure of. So once we have the CIF file, we're just going to go ahead and open that. And make sure the thermal ellipsoids are turned on. And if you're not familiar how to do that, just go to Display, Styles, and make sure the ellipsoids are selected here. And also you want to go to Display, Styles, and Ellipsoid Settings. Make sure the ellipsoids are set at the 50% probability level, and hydrogens are as fixed sizes, 0.2 angstrom there. Next, to actually get the crystal structure packing, what we want to do is select the packing option under Display, and you'll see what you get is the unit cell for the crystal structure with A, B, and C axes. Next, what we're going to do is build on these unit cells and extend this packing diagram out so that we get a large number of molecules for our animation. So to do that, let's go to Calculate now, and then go to Packing/Slicing and click that option. And now what we can do is modify the packing options to extend the unit cells in the A, B, or C axes. What we want to do for this scene is extend the unit cell out in one axis so we get this extended tunnel-like view. So what I'm going to do is set the A axis to 4, and leave the B axis at 1, and then just to fill out the scene, I'm going to set the C axis to 2 unit cells. And you can see by adjusting these parameters, if we take a look at our packing diagram, we can see there's a lot more molecules and that the unit cells have been extended in each of these dimensions. So let's go ahead and click OK. And next what we want to do is now get this into a WRL file so that we can work on this in Mesh Labs. So let's click on File and then Print in 3D. And you can leave the scale at 1 and just make sure you have the correct output directory selected for our new file. And you can go ahead and click Generate. So now we have a new WRL file generated, and we can go ahead and start working on this in MeshLab. So let's go ahead and close out of Mercury software, and then open our MeshLab software. Let's go ahead and import the WRL file that we just created. So select the WRL file and click Open. And this may take a minute due to the large number of objects it has to import into MeshLab. Okay, great. Our WRL file has been imported. You can see that we have the packing diagram, all the molecules imported into MeshLab. So now what we want to do is just export this into an object file so we can work on this in Blender. So let's go ahead and click on File and then Export Mesh As, and then we're just going to export this as an object file, new_1 object, and click Save. And then go ahead and click OK. Now our WRL file is exported as an object file. So let's go ahead and close out of MeshLab, and let's go into our Blender software. So let's start off by deleting the default cube, and then we want to import the object file that we just created. So let's click on File, Import, and then wavefront.obj. And let's just browse to our working directory, and then we want to import the new_1.obj file, and then just click Import Object. And depending on your computer speed, this may take a minute due to the large file size, so we're going to take a pause and come back when this is completed. Great, so our packing diagram has been imported in Blender, and if we zoom out, we can see we get our packing diagram from the unit cells that we created. So now I just want to orient the packing diagram to set up our scene so we can get this tunnel-like view looking down the center of our packing diagram. Let's start off by scaling this packing diagram. So I'm going to just type S, point to enter. And you can see we scaled down our packing diagram. And now I just want to rotate this 90 degrees so that we're looking down that long view. So just type RZ90, enter. And then again, we want to look down the y-axis where we made 4 unit cells back to back. And then finally, I just want to adjust this in the x direction. So type GX-4. Okay, now that we have our packing diagram set in the right orientation, let's work on our camera scene. So just drag select the camera, and then I'm going to type GX-7, and then RZ-45. And then I just want to take a look at the active camera, so I'm going to go to View, Cameras, and then Active Camera. And then next I want to type GZ-3.7, enter. And then I want to rotate this camera angle up, so what I'm going to do is type RX20, enter. And then just to tee this up a little bit more, I'm going to type GX-0.5, enter, so that we're really centering the camera in on one of our hydrochloroquine molecules. Finally, I want to bring this camera in just a little bit closer, so I'm going to type GY2.7, enter. Okay, so now that our camera's set up with the crystal packing diagram, we're kind of looking down the center in this long tunnel type view. Next what I want to do is really focus in on one of the hydrochloroquine molecules by using the depth of field setting. What we're going to do to get this set up is focus the camera in on an object that we select so that we're only highlighting the central molecule that we're interested in. So I'm going to do this by typing Shift-A, and then I'm going to add an empty mesh. So go to Empty and then Plane Axis. And you can see a new plane axis has been added. So what we do is set the plane axis in so that's in the middle of the molecule that we want to focus on. So I'm just going to type GZ and drag that up a little bit, and then type GY and then drag it so that it's kind of in the center of our molecule. So I'm going to do a GZ again, just make sure it's right there in the middle. And then another GX to kind of center that in right there. Okay, great. Now that we have the empty set on the molecule we want to focus on, what I'm going to do is now select the camera and then go to the camera settings and then make sure that the depth of field is selected. We also want to go into the depth of field settings, and it has a focus on object option. We want to make that focus on the empty that we just created. And next we want to adjust the aperture as well, and this gives the degree of blur or degree of focus that goes on in the image. So I want to set this to 1. And then let's just go back to our active camera angle by going to View, Camera, and Active Camera. And then we can go into the Viewport Shading. And now we can see that the molecules that are close to our empty object are in focus, and all the molecules that are further away have a blurred effect or defocus going on. In this scene, we don't want too much of a blur effect because we actually want to see the interactions of other molecules, but we want just enough to focus in on one molecule in the scene. Another thing I forgot to do as well for this scene is to change our rendering engine from EV to Cycles. So go to Rendering tab, go to Rendering Engine, pull down, and select Cycles in the pull down menu. Next, what I'm going to do is set the environment color to be a little bit darker to really highlight some of the molecules. So I'm just going to go to the World Environment tab, and then for our surface color, let's select that and just drop that down to a little bit darker color here. Great, now there's a little bit more focus on the molecule itself. Now I want to adjust the light settings so that it's more directly over top of this molecule. So just zoom out, select our light here, and then just type GX to kind of drag that over to where our central molecule is. And then just type GY to kind of make it right over top there. Now let's just go back to View, Camera, and then Active Camera. Now you can see we get a little bit better lighting for the scene. So now you can see we have our crystal packing diagram set in the right orientation. We have our depth of field set to really focus in on one molecule. Now you can see when we zoom in here that the atoms and bonds are pretty plain. We just have a basic diffuse shading on the surface of the atoms. What we really need to do is add a little bit more texture to these shadings so we get a little bit more complexity to the scene. So let's go over to our scene collection. Let's expand the new object and expand the vertices, and then click on the material. And then we just want to expand the preview here and the surface as well. Let's also go over and click on the shadings option so we can modify the textures in the node editor. And what I want to do is decrease the roughness to about 0.3 so that our texture is a little bit more shiny. And then to get a little bit more fine structure on the surface of the material, what we want to do is add in a bump node. So go ahead and click Shift A, and then go to Vector, and then click Bump. Then just go ahead and connect the normal output to the normal input of the principled node. The next one we want to do is add a texture to the bump surface, so go ahead and click Shift A again, and then go to Texture, and then let's select the noise texture. Next what we want to do is connect the color output to the height input of the bump node. You can see when we do that we get modification of the surface of the texture now. This is a little bit too much, so we really want to adjust these parameters so that we just get a really fine adjustment of the surface. So let's go ahead and adjust our scale to 30. Now you can see we don't have these large pits, but many more smaller pits in the surface. And then we want to increase the detail to 16 as well. Let's go ahead and change the strength of the bumps to 0.15. Now our material is a little bit more detailed, and we get some fine bumps and shadows in the structure that's not just this plain diffuse material. Now let's go ahead and apply these settings to the rest of our atom materials. Go ahead and drag select the noise and bump nodes, and then you can right click and click Copy. Go ahead and select the next material, in this case for oxygen. Go ahead and right click in the node editor and click Paste. And then you can connect the bump node to the principled node. And let's adjust our roughness to 0.3. Now I'm going to do that for the rest of these materials. Just select the new material, right click, paste, connect bump to principled node, and then set our roughness to 0.3. And I'm just going to do that for the hydrogen as well. Paste, bump to principled, 0.3. And for the nitrogen as well, paste, bump to principled, 0.3 on roughness. And finally for the carbon material, connect the bump node to principled node, and then set our roughness to 0.3. Okay, now that we have all our materials edited, let's go to the output properties, and then let's adjust a few parameters to take a look and see what this looks like after we render the image. Let's just adjust this to 50% resolution, and then set our color depth at 16-bit, and then go to Render, and then Render Image. Alright, our image finished rendering. If we zoom in, you can see that we get this kind of bumps on the surface, and instead of this diffuse material, we have kind of a shiny, waxy type material for our atoms. From here, you can really adjust any parameters that you like to get the kind of detail or color that you'd like for the molecules. But basically, our scene's set up. I'm going to adjust a few other parameters, like the environment background, before I go to a higher resolution render. Okay, let's go back to our world properties and just change the color to bring that down just a bit more. And then also what I want to do is select the camera and then type GY, and let's bring this camera in a little bit closer to our central molecule of interest. Okay, let's go back to our output properties tab. Now let's just change this to 200%, And then let's give this a higher resolution render. So I'm going to click on render and then render image. And you can see our image is being rendered at a much higher resolution. So I'm going to go take a pause here and then come back when this is completed. Okay, our high resolution image is finished rendering, and you can see that we have the depth of field set on our crystal packing diagram so that we are only focusing in on one molecule, and everything else in the background is being blurred out. When we zoom in here, you can really see the fine texture on the surface of the material, so it's not just plain diffuse type material. And so this is basically the methodology you can use to import crystal packing diagrams into Blender to create exciting scenes of crystal structures. If you found this useful, please like my video and leave any questions you have in the comments section below. Thanks!